Hello everyone, this is Priyanka of Sri Venkateshwara College of Engineering, and today I am here to present a presentation on the research paper of topic neural networks and deep learning of the subject deep learning. So author of this research paper is Shan Masood. Let's move on to the introduction part of this. So artificial intelligence has transformed over time with neural networks as a key technology. Neural networks mimic the human brain, enabling the computers to learn from data, recognize the patterns, and make decisions. Deep learning is a subfield of AI that focuses on hierarchical learning of data representations through neural networks. Advances in hardware and availability of large data sets have propelled deep learning forward. So, the basic concepts of neural networks are neurons. It simulates the brain cells processing inputs and producing the outputs via activation functions. So, the key components of neural networks are input layers, hidden layers, and output layers. So, there are three layers. Activation functions introduce the non-linearity, allowing the network to learn complex data patterns, example ReLU and sigmoid. Learning process. Weights are adjusted based on error backpropagation to minimize the prediction error. Next is the evolution of deep learning from early perceptrons to advanced multi-layered networks, breakthrough backpropagation algorithm for training the deep networks, growth driven by the larger datasets, powerful computing resources, and better algorithms in the 21st century. So the key architectures that are evolved are CNNS for image processing, RNNS for sequential data, and transformers for NLP. So first is the convolutional neural networks, CNNS. Convolutional neural networks are specialized for grid-like data, particularly for images. So the key features of that model is convolution layers for feature extraction, pooling layers for downsampling, and fully connected layers for the classification. So the applications of CNNS are image classification, medical imaging, and facial recognition. So the advantages of CNNS are it automatically learns the spatial hierarchies of features, making them efficient for large image datasets. Next is the recurrent neural networks, RNNS. RNNs excel in processing the sequential data by maintaining memory of previous inputs. It is suitable for time series data, natural language processing, and speech recognition. So, the limitations of RNS are vanishing the gradient problem in long sequences, partially solved by the LSTMs and GRUs. Applications of RNNs also includes machine translation and video analysis due to their ability to handle variable length inputs. So last is the transformer models. Transformers use self-attention mechanisms to process data in parallel, making them highly efficient. Unlike RNNs, they don't rely on sequential data processing, leading to faster training and inference. Key models BERT for bidirectional understanding and GPT for generative task. Strength of the transformer models are they are excel at handling the long range dependencies in data crucial for NLP and large scale datasets. So modern deep learning techniques are transfer learning, GANs, reinforcement learning, real world impact. Transfer learning using pre-trained models to fine tune on the specific task with less data. Example VGG and RESNet. GANs, generative adversarial networks for creating the realistic images. It is used in the image synthesis, data augmentation, and creative applications. Next is the reinforcement learning. Deep Q networks that learn the optimal strategies from environments. Real world impact. These techniques reduce the training time, resources, and data requirements, allowing more efficient model development. So, here are some of the applications of deep learning like healthcare, finance, autonomous vehicles, entertainment. In healthcare, deep learning models analyze the medical images and assist in diagnosis. For example, tumor detection, disease. Finance, predictive models for stock prices, fraud detection, and risk assessment. In autonomous vehicles, real time perception and decision making in self driving cars. Entertainment, personalized content, recommendations, and automated content creation for the platforms like Netflix and Spotify. So, here are some of the challenges we are facing in deep learning like overfitting, computational demands, ethical issues, bias, explainability. Overfitting, risk of models performing well on training data, but it perform poorly on new data. Computational demands. Training large deep learning models is resource intensive and costly. Ethical issues. Bias in data can lead to the unfair results, raising concerns about the societal impact of AI systems. Explainability. Understanding how deep learning models make decisions is still a challenge, especially in critical applications like healthcare. So, the future directions in deep learning are integration with other AI techniques, hardware advancements, explainable AI, and emerging trends. So, in integration with other AI techniques, combining the deep learning with symbolic reasoning, reinforcement learning for better decision making. Then, hardware advancement, specialized processors, example GPUs, TPUs, NPUs, to accelerate the deep learning. Explainable AI. It focuses on the transparency and interpretability to ensure trust in AI systems. Next is the emerging trends. Hybrid models combining the neural networks with the traditional AI methods for more versatile solutions. So, finally, the conclusion part deep learning's impact, significant advancements across the industries such as healthcare, finance, and transportation. Future potential growing integration with other AI paradigms, enhance the hardware and ethical considerations will shape the future of AI. Next is the call to action. Continued innovation and ethical development are key to unlocking the full potential of deep learning. AI responsibilities. Stakeholders must ensure that AI systems are designed with fairness, accountability, and inclusivity in mind. I hope you all understood. Thank you.